Hi, my name is Jeremy Shulman. You can find me on Twitter as Network Automaniac. And today I'm going to cover the topics of using Excel spreadsheet data. And I am going to cover pulling out data, like how to pull out data out of spreadsheets. But I'm also going to cover some of the related aspects of using data from an external source, like a spreadsheet. So, for the purpose of this tutorial, I'm going to kind of use a use case of pulling out IP address information, and let's say that I want to pull out IP address information from my network, and I want to use that information so that I can populate an IPAM, for example. That's kind of like a broad use case. So generally, the first thing that I would have to do is harvest all that data from my network, go to all the devices, figure out, what IP addresses they're using, pull that out into some kind of data set, whether it was, a spreadsheet or JSON files or whatnot. That's a lot of work just to get the data so that I can, put it in a spreadsheet or use it. So I'm going to skip that entire effort because harvesting data from the network is where people spend a lot of time. But if you have a product that does that for you, as I have here, with IP Fabric, I'm just going to use this system which has already harvested that data for me. So I'm using IP Fabric. This is a commercial software product, and I'm using a data set that IP Fabric has provided for me, so a sample data set. And here what I can find out is the sample data set has 647 devices. And what I want is what they call the managed IP addresses. So if I go into the IP address area here and I click on managed IP addresses, these are all the IP addresses that are owned or managed by network devices. And you can see that for every host, we have an interface and the IP address and the net mask, which is pretty much what we want. But in addition to that information, I might want information about the interface itself. For example, I might want to know what description field that was on the interface, which is stored in the interface record. And I might also want to know information about the device itself. So if I go to inventory, I can see, all of the devices, for example, where I've got the host and the interface. I've got a description field. I've got, the IP address, for example, if it has an IP address on the interface. So, I want to pull this data as well. And then finally, for the devices, for the device records, you can see I have a host name. I've got its serial number. I've got its management IP address, the vendor, what operating system it's using, and what version. So, the first thing I'm going to do is I'm just going to, extract this data set out of IP Fabric using a CSV file. They have export to CSV. And what I'm going to do is I'm going to limit this to site 33. There's all these different sites that are in this data set. I'm going to use site 33. And if I click on this button here, it's going to download just these 14 items. And likewise, for the interfaces, it would just download just the interfaces for site 33, which happens to be 212 items. So I've done that already, and I've loaded that up into a spreadsheet. So this is the spreadsheet that I've loaded it into, so I'm kind of skipping those steps just in the interest of time. You can see I've got the devices page, just with the same column names and the same data from the IP Fabric system. The interfaces, same thing, and the IP address, the interface IP address. So one of the types of things that I advocate for is learning how to pull data out of a spreadsheet, because oftentimes within a company you're sharing information between members of your team or even different teams in your organization, different departments, for example, and you share information with spreadsheets. And so one of the tricks or one of the issues with pulling data out of spreadsheets is you're going to get a spreadsheet perhaps that you didn't create. So this is kind of why I'm using this as an example. I didn't create this spreadsheet. I had a tool create this spreadsheet for me, but just imagine if you had, some other team in your company create a spreadsheet. And so there's a couple of things that you're going to need to deal with. One is this top row here, which is what you would call your headers, if you will. you're going to want to pull data from the spreadsheet, but you're going to probably want to change what you call each of these elements inside of your code, because you don't necessarily want to have, a field in your data called IP space address. Maybe you want to just call it IP adder, for example. So we're going to cover how to pull data out and, change, the header names, for example. The other thing is validating the data that you get. For example, let's say you got data, and in this case I have VLANs, and let's say, for example, somebody, put in bad data. In this example, I have a tool that generated the data, so, I can quote trust it. But, let's say that this data came from somebody else and they, type it in or they copy it and paste it. What if they accidentally, typed in an IP address that wasn't an IP address, or they put in a interface name that, wasn't an interface name or wasn't a valid interface name for that device. So making sure that your data is good before you even start to use it is a skill set or a problem or an aspect of using, data from third parties or external sources. So that's kind of the whole build-up to what I'm going to show you. I am going to use a package called openpyxl. And I'm going to take you through every step of the things that I've talked about. So let's get started with that. I've got blank file here, and I'm going to say from openpyxl. I'm just going to say actually import openpyxl. And if I wanted to create a workbook, I would just say, open, and I give it the file name. In this case, I'm going to say this is the file name of my Excel spreadsheet. And just doing this will open up, that workbook for use. And what you can see here is I've got 3 tabs: devices, interfaces, and IP adders, or interface IP adders. And so what I'm going to want to do is I'm going to say devices is, from that workbook, I want devices. And that is going to give you that sheet. So what I'm going to do is here in this, this window, I'm just going to start demo py. And I'm using interactive Python, so we get some colorization here. And I can see, workbook is a workbook and devices is the worksheet devices. Now, what we want to do is, the first step is we want to transform all of our data from this worksheet into dictionaries, right? So we want to have a list of dictionaries. And the way that we do this is we can read in all of the content of this worksheet by just saying devices values. And values is a generator. So if I were to list all of the values, what you're going to get is essentially records. Every single one of these is a record. So actually, if I do this, I'll just call this records. If I said records 0, we can see that is actually the first row. And if I said records 1, we can see that this is actually the first actual record, in our data set. So what we really want to do with record 0 is, we want to pop off the first record, because really that's our headers. Right? We can say that these are our headers. Right? This is our header row. And so we have all this none data here. And really the reason why you see that is if I were to scroll kind of across here, I have a whole bunch of these columns that are empty. So the way that you get rid of these nones, and this technique that I'm going to show you only works, presuming that you've got your headers, contiguous. There's no empty columns here. I would say headers is actually equal to, I'm going to filter out none from headers. So now I only have, the actual headers. Right? These are my columns. Okay. And if I look at the length of my records, I should have, 14, which I do. And what you can then do is you can use something in Python called zip. And what zip does is it will take two iterables, right? So headers is an iterable, it's a list. And I could take, for example, let's say I had row is going to be records of 0. Let's say I had just a single row of data. Now, if I zip the headers and this row of data together, what that's going to do is going to give me a generator called a zip. And if I were to actually list this out, what you can see is that it has kind of combined a one-for-one, from headers to rows. So it says, it takes the first element from headers, it takes the first element from rows, takes the second element from headers, it takes the second element from rows, and so forth and so on. And you can see that this is a tuple. So rather than using list, you can actually use dict, and that will actually create your dictionary. So now if I said, dict zip headers row, and I just saved it back, now I have, row hostname, right, or row version. So if I wanted to apply that same technique to all of the data, right, for all of the records, I could do something like this. I could say, I'll just call it, records data. And I could say dict zip headers row for row in records. And now what I have with records data is a list of dictionaries. So, this is pretty quickly, if I wanted to create a function called, let's say I said load sheet, and I had sheet name, then what I would do is I would say sheet is equal to sheet name, and we'll say headers is equal to actually say records is equal to sheet values. And we want the list of that, and then we want headers is equal to records pop 0, but we want to filter out none, and then we want to return dict zip headers row for row in records. Okay, so once we have that, we'll restart our program, and I'll say load sheet devices, and now I have devices. So it's basically read all of that data. And I could do the same thing for my other sheet names. So I think there's a function called get sheet names. So I could do, interfaces is equal to load sheet interfaces. And if I looked at the first record here, I can see that I have, the data pulled in. And same thing with, interface IP adders, load sheet interface IP adders. Same thing. Okay, so that's kind of step one. How do you load data from a workbook with many sheets, and how do you pull it into a list of dictionaries so that you can do something with the data? Okay, so the next thing that we want to do is we actually want to transform these records of dictionaries into objects that are parsed, so that we can do two things. One is we want to change the field name here, which we could have done by changing the headers, but I'm going to show you another perhaps better way to do it. But more importantly, I'm going to show you how we go about ensuring that the data that we get is valid. For example, did they give us a valid IP address, or did they give us a valid IP network? And I use a package called pydantic to do this. Pydantic does two things really. It serializes JSON or dictionary data like this into an object, and it also performs validations. And so primarily I'm using it right now for validation to make sure that the data is good, or transform it if it's not, or report it if it's bad. So I'm going to do the devices first. So I'm going to say from Pydantic import, and what we're going to do is Pydantic uses this concept of a model. A model is what defines the object fields. So there is something called a field. And so let's do the first one for device. So I'm going to make a class called device model that inherits from base model. And here is where we're going to do two things. We're going to define the field that we really want to use in our program. So rather than calling it host name with a capital H, maybe I'm going to call it host name, or maybe I'm just going to call it host. And with Pydantic, we're using Python typing. So I'm going to say this is a string, and it has an alias to host name. So really what we're doing is we're saying when I present or when I create a device model instance, if my dictionary has a key called host name, it's going to take that value, it's going to make it a string, it already is one, and it's going to store that as host. So let's say I did that. So I'm just going to kind of copy and paste some stuff here. Make this easier, like this. So if I said device model, and let's say I want to take one of our device records. So I have devices, so this is a dictionary. And if I said device model parse object, because that's what I have here, I'm going to say records 0. Oops. Oh, sorry. Devices sub-0. Device model parse object devices sub-0. Give me a device object back. And you can see I have a device object and it has a host. Because it's the only thing I've defined for this model. So I could actually reference it as host. So I would do the same thing for each of the fields that I want. Now I might not want all the fields that are in that spreadsheet. So in the spreadsheet I want site, I want serial number, I want management IP. So let's do those. So let's say I want site, field, alias, site. I want IP address, which is, for right now I'm going to say this is a string just to start out this way. And this is management IP. Let's see, let's get vendor, family, and version. So vendor is field alias vendor. OS name, I'm going to call it OS name because that's what I like to use. And this is going to come from the family field. So this is going to be alias family. And we have version, OS version, string field, alias version. And then I think there's another one for model that I might want here. No, this data set really doesn't have model, so I won't use that. All right, so this is what we can do so far. So if I were to copy and paste this and do the same device object, you can see that I now have these values, set in here. And if I wanted to, do all of my devices in the same kind of way, I could do, device objects is, and in this case, we want to parse the object, I'll just say rec, for rec in devices. And now we have, a list of all of our objects. And this is a list. So, we could treat it like any other list, but, we can see that we have, our devices. We can see we've got the fields, for these devices, structured in a way that we want by their object or the attribute name. But let's say that we wanted to turn these into IP addresses and so that we could manipulate them as IP addresses rather than these just string values. So what we can do is we can use something that's built into Pydantic called any IPv any address. So this will parse it as either an IPv4 or an IPv6. And so rather than a string, I'm going to call this IPv4 any address. Oops, because I didn't import this. Actually, why don't we just do this? Just exit out here and we're going to restart. All right, so devices is load sheet devices. And now we could say, if I wanted to, I would just say device model parse object row for row in devices. And now we have, the same thing. Now, if I wanted to be, clever, I could, pass this model into my load sheet function, which I'll do. So I'll say model here. And rather than returning a list of dictionaries, what I could do is, produce a list of models. So I'm going to break this out slightly differently for a reason later, but I'm going to do it now. So I'm just going to say for row into records, I'm going to say items is a list, and I'm going to say items append, in this case, model from object, or I'm sorry, parse obj, and we're going to say as dict is equal to dict zip headers row, right? So that'll give us our dictionary. We'll parse it from as dictionary, we'll append it, and we'll return items. Okay. So now that we have that, we could say devices is load sheet, and we're going to load sheet from devices, and our model is going to be device model. So we've kind of combined those steps all together, which is kind of nice. And you can see that my IPv4 address, is an IPv4 address, which means I can treat it, like I would treat anything from the IP address module. So let's say I wanted to sort this list based on the IP address. I could I can do this. I could say from operator import attribute getter. And because I want to get the IP adder attribute, so I'm going to say devices sort key is attribute getter on IP adder. And now if we looked at this, this list is now sorted by IP address, which it is, because that's cool. So now we've got our objects here. And we validated at least that the IP address is parsed. But what happens if it's not a good IP address? So let's go in here and let's kind of muck with it. So let's change this value here to be dash dash dash. Right? So now it's not a valid IP address. Click save, and I am now going to reload this, and now I'll do the same load sheet keys, and now it's going to tell me that, hey, I got a validation error. It says, hey, I got a validation error, management IP address, but this doesn't tell me what row it came from. It doesn't tell me what the bad IP address is. It really doesn't tell me anything other than something bad did happen. I got this thing called a validation error. Okay, so now what I'm going to do is I want to catch that exception. I want to say try, and I'm going to say except validation error, which comes from here. exception. And let's just kind of print it out and exit the program. So let's import sys, and let's do sys exit, you know, bad value. And this exception has errors in it, so I can say errors, and I can't quite remember what I get here, so let's take a breakpoint and run this again. I'm just going to make it run, so I'm just going to say devices is load sheet devices device model. Okay, so I'll get into this breakpoint and I'll look at, this is my exception, and I can see I've got errors, and I've got something called JSON here, so let's see what that does. Print exec JSON. Okay, so I'm just going to dump this out to the screen, just, you know, for now. So let's say bad value report, and we'll just kind of accept JSON, and I can do that. But I kind of want to know, you know, which record, which row is bad. So for that, I can do enumerate records, and this will give me my row number. And then I can say bad row number, and let's do that. And this is the report, and let's say I wanted to print out the row data itself, because I have it here as a dictionary. So we'll do import JSON and bad row data, and we'll do JSON dumps row indent 3. All right, so hopefully this will give us everything we need to know about what went wrong. Okay, so this tells us we've got, you know, bad row 3. We know that it's the management IP address is bad. And if we look at the bad row data, this is just the row data. So really what I wanted was the dictionary data, actually. So as dict, that would be more useful. Okay, so now we can see, you know, bad management IP address, and we can see that our management IP address has the dashes in them. So this kind of picks up and validates, you know, the data, and tells you, you know, where the data is wrong in your spreadsheet. This is really important because you might get, again, a spreadsheet from, you know, somebody else, and there could be, you know, typos, there could be mistakes. So I'm gonna take that out there so that it doesn't, you know, so that it's not bad. And we can run this, and then we're good again. Oops, I forgot to click save. Save. Okay. And we're all good. So now we have devices again. All right. So, you know, is there anything else we would really want to validate, you know, in this spreadsheet or in this worksheet? Probably not. I mean, we could validate that the vendor was a valid vendor if we wanted to. You know, we could validate that it's, you know, one of these values. We could validate the family if we wanted to. But hopefully you kind of get a sense of where I'm coming from with the terms of validation. All right, so let's kind of move on to the interfaces page. We're going to do something pretty similar. You know, we're going to say we want the host name, the interface. What else do we have in here? We're going to want the description field. Maybe I want the MAC. I definitely want the IP address. Looks like I actually duplicated my data when I imported it, so I'm going to get rid of all of this. Bad import. Okay. So let's kind of do the same thing we had before. With device model, we're going to do interface model. So let's see. Let's do interface model. I don't really care about the site in this case. It has an IP field just called IP. Let's say I want a description field alias description. Let's say I want the MTU, which is an integer. Field alias is MTU. Let's see, host name. We want the interface name, of course. Yeah, let's just leave it at that. All right, so we want the interface name. Interface. Okay, so now we'll do the same kind of trick. We'll just say interfaces is load sheet interfaces, and this is going to be interface model. Okay, so let's do that. All right, so it looks like we got some bad data. Bad row on 0. IP address is not a valid IP or interface. Okay, so that's right. Row 0 doesn't have an IP, so it's optional. So the way we would do that is we would say from typing port optional, and IP address is optional. So we would just say optional here. And we can try it again. Okay. Now it says it's still bad because what's happening here is it's an empty string. Okay. And what we want to do is we want to convert anything that's empty to a none value so that the optional, looks at actually the value none. Because what's happening is it's trying to take the empty string and run it through the IPv4 or the IP address functions, and it's coming up with an exception. So what we could do is, we could apply a rule that says before I run a validation through these fields, I want to check to see if it's empty in any way, and if it is, let's make it none. And part of pydantic allows you to do this using a validator. So I'm going to import a function called Validator. And what I'm going to do is and this is used as a decorator, and I can apply this validator to every single field, which is by using star. Normally you'd put the field name here, but I want to use this validator for every field. And I want to run this validator before it's actually been converted. So by using pre equals true here, what I'm saying is before the value is converted to an IP address, for example. So I'm going to make a function called empty is none. And what this is going to do is this is going to return the value if there is a value. Otherwise, it's going to return none. And the difference here is an empty string is going to come back as a false Boolean expression so that it'll come back as none. All right, so if I run this through here again, this tells me that, okay, now I've got description. So I've got description is empty. So let's do the same thing as description. It's optional. Optional. Okay, and MTU, we've got MTU, none is not an allowed value. MTU, again, let's go with optional. MTU apparently is not provided on every single record. All right, so now we have some interfaces. All right, everything looks good. If it doesn't have an IP address, it's none. If I wanted to look at all the MTU values, I could say MTU for I in interfaces. These are all the MTU values. I can see I've got nones in here. I can see some values. You know, if I wanted to look for the, you know, all MTUs, say what's the minimum value for all my MTUs. Oh, it doesn't allow for none type, so I have to say val for val and if val. Okay, so that's my minimum MTU value, and my maximum is some really large number. So if I wanted to actually enforce a minimum for my MTU, I could say greater than or equal to some value. For example, in my case, it would be some 1400 value, 1472. But let's say I didn't know that. Let's say I said all of my MTU values have to be at least 1500. And if I ran through this, it's going to tell me that on row 40, I have a bad value. The MTU is 1472. So if I go back to my spreadsheet and I look at row 50, or I'm sorry, what was it? It was row 40. Row 40. I can see that this is not 1472. 1472 is on a different row. So what I need to do is I have to adjust for the fact that my first row is 1. Which means that as I go through my enumeration, I want to say start is equal to 1. Actually, start is equal to 2 because we've skipped the first line. So now I'm going to say start is equal to 2. Let's do that again. And now we should get bad row 42. And everything should line up. Okay, great. So that's how we can make sure that that's correct. Now, in my case, actually, I really want to make this 1400 so it passes. All right, so the other thing we want to do is we might want to check to make sure that this sheet, the host value, is an actual valid host. For example, you know, what if somebody accidentally, you know, changes value here to some bad value? If I save that and I rerun our program, oops, MTU is 0. I've got on line 14, oh, so here's a case where I have a value and it is a value which is 0, but it's string 0. So the reason why it passes here is because it's string 0. So what do we do about that? Well, we could do a couple different things. We could clean up our spreadsheet to delete the zeros. We could make another validator or something to manipulate, you know, the MTU value in advance. So let's see, what should we do? I'm gonna just clean up the data because this might be something we need to do. So let's get rid of every row that's 0 here. Let's just delete it. And this might be something you have to do, you know, when you get data from somebody, is like you might just have to clean it up. But if we wanted to clean it up programmatically, how might we do that? Well, we could do this. We could say validator MTU and do the same trick. So let's do pre is equal to true. And we could say, you know, def validate MTU value. And we can say if value is equal to 0, then return none, else return the value that we have. And let's see if that works. Okay, so that looks like it worked. And now we should not get any 0 values they're all going to be none. You can see that it loaded okay. So that just shows you another way to, how do I deal with data that, I don't quite want to know what I want to do with. And again, when you use pre equals true, it's checking the data before it runs through the conversion, because at the end, the MTU is an integer. For example, here MTU is a number. It's not a string, so it's been converted for us. And it's important that the order in which you place these validators is the order in which I think it's going to get executed. So because we're doing this MTU first, this is going to happen before this validator is run. Okay, so what if we wanted to check the host? Because remember, I kind of made an entry here where I messed up one of the host values, and I can't remember which one it is, but now I have a bad host value. So what you could do is you could say, I want to validate the host, and I want to compare it against any value that's in my devices. So I'm gonna do kind of a little bit of a more advanced trick here, or technique, and I want to make a function called find device by host name. And the way this would work is I would say, I want to find a device. So found is equal to, let's see, for dev in devices, if dev host name is equal to host name. Actually, I called it host. So let's just keep everything kind of consistent. And so I'm going to do next, and next is going to return essentially the item that was found, and if it doesn't, it's going to cause a stop iteration to occur if it's not found, because that's the way next works. So I'll demonstrate that just for the sake of example. If I say find device, and I say foo doesn't exist, so I get this stop iteration. But if I look at my devices, I can see this is an actual device. So if I say find device, no error. Okay, so I know that if I don't want an error to occur, I can just pass next. A second thing, it says if I don't find anything, just return this default value, which is none, and I'm going to return that. So I'm either going to return none or the device record that was found. Now, because I'm going to do this again and again and again and again for any given host, I'm going to turn this into a cache so that I don't keep doing this lookup function for every host. This may be a silly optimization, but with a large enough data set, it might be useful. So I'm going to show you the technique. So from func tools, import LRU cache. And we just make this an LRU cache. And when you do this, if I search for something once, it'll do a miss. And if I search for the same thing again, it'll do a hit, and it won't execute through this code. If you've never seen an LRU cache in Python, you get to see one now. So if I did find device, it returns me that device. And an LRU cache actually has some functions built onto it. So you can see that one miss, because that was the first time, 0 hits. And if I do it again, you can see it got a hit. So again, maybe a little silly, but I like doing it that way. The trick though is how do I tell this interface model that I want to use this function? Okay. One of the things Pydantic doesn't have is the built-in concept of passing around context data. Which is, again, context data. Think of that as additional information that your program could use in context to the model. It doesn't really have that by default. And so after some research, the way that the workaround or the approach to doing this is to actually just kind of create what I would call a fake field. So in interface models, let's create a fake field called context, which could be anything. So All right. Now, we don't want to save context. So we want to use it. But then when we're done with it, we want to delete it out of this model. So I'm going to show you using it, and I'm going to show you how we delete it. But what will happen is I want to pass in a context. So I'm just adding this here. My context is going to be find devices, or find device is the function find device. Let's kind of make this look nice. Okay, so load sheet doesn't take something called context. So let's make it take something called context. And what we're going to do is, rather than parse object, we are going to parse the dictionary, but we turn the keywords into keyword values. So this is basically flattening the dictionary as keyword value pairs, which is another way to pass data to create a model. And then we're also going to do context is equal to context. All right, so let's give this a shot, make sure it runs without blowing up. All right, so I haven't done anything with this context yet, but I passed this function. So what I want to do is for host, I want to create a validator on host. And in this case, I'm going to call this def v host. And the value in this case is going to be the string value, but you can also do values, and these have to be as they are shown. You can't just make up any parameter name. Pydantic looks specifically at the signature of this function for value and values. And if you pass it values, it will pass to you all the current values it has parsed, which in this case, because context is first, it will always have context. And so I'll kind of demonstrate that here. I'll put a breakpoint in so we can see it. Okay, so we're here in that function. I can see this is the value. And if I look at values, I can see that there is something called context, because that's what I called it. And context is a dictionary, and it has a function called find device. So if I actually used values context find device, which is a function, and I passed it the value, it would actually say, oh, I found that value. That's great. But if I passed it some bogus thing, it would return back none. So this is what I want to do. I actually want to do this exact test. I want to say, if it isn't found, basically, I want to raise a value error. And I'm going to say device, or we'll say device is unknown and value. So when you're using Pydantic, the way you tell Pydantic if something is not valid is to raise a value error. Otherwise, we're going to return the value, because a validator has to return a value. Great. So now we run this, we can find out, sure enough, we have a bad host on row 28. This was the bad value. So now I can go back to my spreadsheet. I didn't know where it was, and go to row 28. Yep, sure enough. And fix it. All right. So that is the technique for if you want to kind of chain validation between things that you've loaded and other sheets. This is a way to do it. I'm not saying it's the only way to do it. I like doing it this way. So that's this technique. And let's do one more model, and then we're gonna kind of complete the exercise. So let's take a look at our IP interfaces. And again, in this case, we want the host name, the interface, the IP address, and the network. So let's do, I'm just going to copy a lot of this. All right, and I'll call call this interface IP model. Okay, we are going to get rid of that, get rid of that. We'll leave that. Now we have a network, and now in this case, it's not optional. We know we're going to have an IP address. And this is called IP address. So this is called IP address, and this is going to be a network. So there's another thing called IP any network. IP any network. Field alias is network. So we want to do the same host check, right? So we'll call this IF IP adders load sheet interface adders. It's going to be our interface IP model, and our context is equal to, let's do the same thing. Actually, I'll just copy this. Right. So for right now, we'll just do that. Make sure it works. Oop, I forgot to click save. Okay, IF IP adders. Right. Okay, so we have the IP address and we have the IP4 network, so we can see that. Now we have this context data, and I forgot that I wanted to get rid of it. So the way you can get rid of it is through another pydantic mechanism, which is a root validator. So there's something called a root validator. And what a root validator does is it runs after everything has been loaded. So in this case, I want to have a root validator, and I'm going to call this, delete context. And this takes values. And so I just want to say delete values context because I don't want it anymore, and return values. That's pretty straightforward. And I'm going to do the same thing on this guy. And so let's run this again. IF IP adders, and you can see that the context has been kind of cleaned out. So, this idea of, having a context variable, or you call it anything you want, but having a context variable and then using the root validator to get rid of it. I found this in the GitHub repository for Pydantic as, kind of the discussion in one of the issues, because they don't support, context built in, at least not yet at the time of this video. Okay. So I guess the only other thing that we might want to check is, the interface name, to make sure that the interface names match, because again, maybe we fat fingered the interface name here, and we're going to use this tab as kind of our source of truth to make sure that it's valid. So similar trick, that we did here with find devices, you could do with, find interface. So let's say this was host and IF name. So we might want to say, in interfaces, I'll say this is actually an IF interface record. And in this case, we want to say if iface host is equal to host, and iface if name is equal to if name. Right. And then we'll do the same thing with this. We'll just add another context variable called find interface. Find interface. Great. And then we'll do the same kind of technique here. And we'll change this to ifName. This function can be called anything you really want. It doesn't have to match. But we'll do find interface. In this case, it takes two functions. So values host is going to be one of them, and then that will be the other one. And we'll say device interface is unknown. And let's see if that works. All right, and then let's screw something up and see if it catches it. So let's screw up this one. Save. Yep, sure enough. Unknown device interface, you know, the one that I screwed up, tells me it's on row 26. Go fix it. Save this. All right, and then I have all my adders. Right, and you can see, you know, for example, I've got this in my network, you know. So again, I can use this data any which way I want. So if I was trying to generate a report or produce other data or interact with an API, now I have, you know, all of this data, you know, in a form that I know is, quote, valid and programmatically accessible, meaning, you know, I can use it in a way that lets me easily transform or manipulate the data because it's been converted into a format that I want. For example, the IP addresses are, you know, this IP address object type or an integer, etc., etc. So hopefully this video has been, you know, informative, shows you, you know, some simple techniques for pulling out data out of a workbook. Again, pulling data out of an Excel spreadsheet really is not the difficult part of the process. You know, really in 4 lines, you can pull out data, you know, and turn it into a dictionary. The real hard part, at least in my opinion, is, you know, first and foremost, making sure the data is valid and then to transform it into a structure that makes it easy for you to use it, you know, if you were going to do some programming exercise. For example, in this case, now that I have all of my IP addresses and IP networks, you know, I could very quickly, you know, tally up and say, find all of my IP networks and all my IP addresses so that I could then go into my IPAM and update it. You know, for example, I could say from collections, import default dict. So let's say I wanted to make a collection of all my networks. I could do something like networks is equal to default dict list. And then I could say for IFIP in IFIP adders, networks, IFIP network, append IFIP. And then I can see, you know, what are all the networks I have. You know, these are all the unique networks that I have. And for any given one of those networks, I could find, you know, all of the IP addresses. For example, if I wanted to find, well, let's just do that. Let's just say, you know, for network items in networks items, we could say print network and count is equal to, or just leave it count as len items. Great, so I can see, for example, in this particular subnet, I've got 3 items. So if I wanted to look at that network, port IP network, because I have to turn it into one, IP network. You know, I can see that these are the IP addresses in that network. So, you know, if I was trying to take this data and stick it into an IPAM, I know the network, you know, I know the IP address, I know exactly what interface it's bound to, I know exactly which host it's bound to. you know, any of the data that I want in order to put into my IPAM, for example. If I wanted to know what the description, if there was a description for one of, you know, for this particular interface, I could look in my interfaces collection. You know, I could pull out the description value, you know, if there was a description value. So all of that is now accessible and programmatically accessible to what I want to do. You know, and while this seems like it may feel like a lot of work to do because I kind of went through it, you know, once you get the hang of it, you'll find that using this kind of object model method will help train your brain and will actually allow you to explore some of the more advanced capabilities of modeling. So hopefully this was a nice little introduction to modeling, an introduction to Pydantic. There are many libraries like Pydantic out there. Another common one is called Marshmallow, but I happen to use Pydantic. You know, every one of them has their pluses and minuses, but you know, I like Pydantic. So again, hopefully this has been informative. And if you have any questions, you know, feel free to post them under the video link.